Thanks very much for this opportunity to talk today about the eWater source modelling platform, River Basin modelling. This platform was developed in Australia to support good water management in an environment where we frequently experience a lot of water scarcity. I thought I'd start by talking about the drivers for the creation of the Source River Basin modelling platform. I think many people may have heard of the Murray-Darling Basin in Australia. That's shown here on the right of the screen. A good example of our, or perhaps an indicator of our problems with the environment are flows from the mouth of this river basin, shown by the point of the arrow there. So we have 1 million square kilometres of basin in the Murray-Darling, and this all flows to the Southern Ocean at that point. But in 1981, the mouth closed, and for several years afterwards, the mouth closed. And then for a whole decade between the year 2000 and 2009, there was no flow through the mouth of this basin. And the reason this obviously had a lot of ramifications upstream as well as at the point of the opening. But this occurred because of the harsh drought in that decade, 2000-2009, but also the historical overuse of water in the river basin. So let's stick with this Murray-Darling Basin. My next slide talks about inflows to the Murray-Darling Basin. Here you can see it's got an average inflow of about 32 billion cubic metres a year, but you'll also notice that in most years we're below the average for inflows. And you can see there that longest drought at the end there, the longest, deepest drought on our historical record of 120 years, is that period between 2000 and 2009. But also it's very important to note that the variability of these annual inflows. There's an order of magnitudes difference between the low values of inflow and the high values of inflow. This creates a very difficult system to manage water resources in. So this model, the Source River Basin model, was designed to support better management in these sorts of conditions. The model came from a period of research and development over 20 years, from about 1992 through to 2012. In 2012, the government said we no longer want to support a research and development program. We want you to establish a company, eWater, a government-owned company that can be the custodian and the developer of models and tools that have been developed in this previous 20-year period. And also in 2012, the Source River Basin model was proclaimed as the National Hydrological Modelling Platform, which means that when the states in Australia want to discuss water sharing, they must use the model in that discussion. So since that proclamation, and before and after that proclamation, there have been a lot of models developed using this platform, many in the Murray-Darling Basin, shown here as the blue area, but many also up in the catchments flowing out to the Great Barrier Reef on that northeastern coast. We have a lot of users internationally as well. We've approximately 3,500 users internationally, and you can see most of those are in Australia, but more than a third of them are international users of this model. So let me talk very briefly in the limited time available about what the source model is exactly. In its simplest form, it's a node-link model where a node represents a hydrologic process or a control structure or a gauge, and a link moves water through a network. We can develop a node link model through using a schematic editor or through the geographic wizard. We also have nodes to represent water management rules. So just briefly, this is an example of creating a catchment model. We use a digital elevation model that can generate a series of subcatchments which are linked from the upstream subcatchment to downstream subcatchments. The other approach to develop a model, these two different modes of use can be closely linked if you wish, but we can just draw a network using nodes and linking those appropriately. And you can see here that your nodes, there's a node there for a dam and reservoir, another node downstream of the dam for a water user. So in that water user node, for instance, we might have an irrigator, a model that can represent an irrigation area. And here you can see on the left, we list our different crops: cotton, wheat, faba bean. Also, we need information about evapotranspiration and rainfall, and then a descriptor of the crop, the canopy, the root zone, etc. So there are a number of different ways we can represent water demands in our system. And because we have a lot of flexibility in that regard, we call it a platform rather than a model, because people like to choose their own approach to representation of particular fluxes, and indeed you can write your own plugins to represent different components of water balance in your model. So once you've represented all your processes and structures within your river basin, the source model looks at the supply and demand. So we might have the runoff generated by rainfall, the water stored in the dams, water in geological reservoirs, and then we have the demands on those. So we might have demand from irrigation, a demand perhaps from the energy sector. We have our drinking water requirements from cities and urban towns. And in Australia, we have a particular focus also on environmental demands. And this model looks at all of those things together and overlies the policy dimension. So what are the rules for sharing water? We have a certain available water volume. How are we going to share that between our cities and our irrigators and our industries? So to explain a little bit more about how the model works, I'm going to talk about a couple of examples. Unfortunately, due to lack of time, I'm only going to do two examples. So my first one is the Murray-Darling Basin again. I've got some slides here from the Murray-Darling Basin Authority that give you an idea about how they use the model. They consider their model of the Murray River to be the science behind the decisions they make. They use it to simulate the impacts of water management and water management policies on the system. They try to explain what has been happening in the past, and to predict what will happen in the future, and to predict what will happen if they intervene with a new management approach. And here is their model. It's a bit hard to see. Water flows from the top of this panel to the base of the panel. But then it flows into the second panel at the top and out the bottom, and the third panel and the fourth panel. So we've got here a very complex model to represent a very complex system. There are more than 880 nodes in this system. And this is required to cover the complexity and the number of different water users and water demands on this system. They use this model for planning, for instance, water allocation. How do we allocate water to different users within our basin? Also for prediction, what do they expect flow to be at different points in the basin? What will the salinity of the water be at those points? They also use it to audit their plans. So we plan, especially in the Murray-Darling Basin, we have a cap on total water use, the total annual diversion of water, and they use the model to help them do the water accounting required to track whether we're sticking to our cap, whether we're overusing water or sticking to the limit that we've all agreed to keep to. I just want to talk very briefly about evaluating new management. So here we need to consider what are the components of the basin water balance under a baseline or a current condition, and how do these components change when we change our management? And are these the changes we were looking for? And the most important thing is that we need to involve a wide stakeholder group when we're evaluating which are the important components and how do we use those to assess our management within a basin. And these identified components, we call them indicators. Now this little figure down here on the right, the red line shows the salinity in the Murray River, the salinity that would result if there was no intervention, no interception of salt inflows into the river. And the blue line shows the salinity they were able to achieve when they intervened and pumped saline water out of the system before it reached the river. So we can see quite clearly here what the effect, what the benefit is of that intervention program. I'd now like to move on to an example in the Nile Basin, El Fayoum. We're doing a pilot modelling project there. This image here is a satellite image showing the delta irrigation area and the Nile River coming in, the green strip coming into the delta. And off to the west here you can see the circled area. That's El Fayoum for those who don't know. And you can also see in the picture, or maybe not, it might be hard to see, but there are two lake systems. And both of those are terminal lakes. The water levels in those lakes are below sea level. So it's an internally draining basin, El Fayoum. We're doing a pilot study here with the Ministry of Water Resources and Irrigation, with the planning sector. And I'd like to thank the modellers from the sector who have sourced information for this model and who are working with us on it. At the moment we've done two primary parts of the pilot study. One is to build a model of the irrigation area, and we're now starting to use the model to demonstrate functionality of the eWater source approach. So the model is presented here. Again, I don't expect you to be able to see what all the nodes are, but there are two arms, two main canals in this system. There's the Bar Yusuf Canal, which is the one shown at the top of the figure, and Hassan Wasif system at the base here. And in both of those systems there's a large urban water demand, but an even larger irrigation demand, of course. And they're both represented in those two canals. So we've developed this model. We're now trying to look at whether we can use it to find optimal solutions for growing cash crops, cotton and wheat in the area. And we have an optimisation tool in the source modelling platform, and here we're considering three objectives. One is to maximise the cotton productivity, the second is to maximise the wheat productivity, and the third is to minimise the volume of water that we use on the cotton and the wheat. And our decision variables in this case are the area planted to cotton and the area planted to wheat, and we have a constraint that we're not allowed to, we don't want to increase our cropped area by more than 61,000 hectares in addition to the subsistence crops that are already grown. So I'm running out of time, but I'll move straight to our the picture of the results here. This this is a three-dimensional plot of optimal solutions from the optimisation. The circle that's numbered number 1 is the circle that uses the least water. That's the target area if you were aiming to use the least water. Circle 2 shows the area with the greatest wheat production, and Circle 3 shows the greatest cotton production. And all these solutions in between are optimal solutions that a manager might choose. They might say, well, don't worry about the water, we'll just go for maximum productivity of cotton. Or they might say, we need to moderate our use of water. We only want to use half of the available water, and therefore we'll choose one of those blue markers somewhere in the middle of our figure here. So this represents a very initial stage in our analysis of Al-Fayoum. We want to develop and change our objectives to make it more useful to management of this area. One thing I'm wondering about is whether we should have an objective to ensure that there's always some drainage to the lakes. And also, rather than assuming a constant annual water volume, which would be a part of this 55 BCM per year from the High Aswan Dam that we talk here about in Egypt here, that we might look at different total volumes, maybe reducing by 20%, 30% in the Al-Fayoum area. And also maybe looking at variability of the available water volume, because certainly in Australia we have a huge amount of experience with variability, and I think that's the case in most countries. Certainly in India I'm finding that it's the variability that people are interested in. And we've seen earlier in this conference, in the 1980s the High Aswan Dam had low water volumes, so the available water volume would have been reduced in those years, of course. Also climate change. Dr. Hesham El Askari presented some interesting information on that, and the Ethiopian Renaissance Dam as well. Aris Georgakakis talked about that. And if we are going to plan for regional cooperative water management, we should expect to see some variability in the available water for Egypt. So we also could look at water use efficiency, how best to utilise any advantage gained from improved water use efficiency of crops, and also the use of non-conventional water. So these are the things I'm hoping to look at with the study group in the planning sector. Finally, just some take-home messages. River basin models, and one might say models generally, are never 100% correct, but they still can be useful. I think it's already been said in this conference that you can't manage what you can't describe and measure. And once you can describe a process and a water balance within a system, then a model is a good place to store that knowledge and understanding. We build models with the best available data sets, and then we use the scientific methods appropriate to the data available. Models provide inputs to water management decision making. They're a repository of knowledge and information, and they're a valuable communications tool for all stakeholders. That's the irrigators, the water managers, the dam managers, the environmental managers, and the modellers themselves. And continually we're getting new and better data sets and changing conditions. And in Australia we recognise that this requires a continual cycle of renewal and update. And it's through this cycle of renewal that you can engage your stakeholders most successfully. And even today, the first speakers talking about satellite data sets. We are working currently on using satellite data in the source models to help us build a more representative river basin model for areas where data are limited. Thank you very much.